everyone. Good afternoon. Okay, so today we are actually going to be doing more integration. In fact, this one is a small part of integration, but I'm gonna go slowly for this chapter because most people find this chapter difficult. So, okay, I was checking my mic. Testing. Okay, that seems to be working. Okay, all right. Okie dokie, right. Let me just move this out of the way. So, do you guys have anything you want to ask from the last exercise? I think it was exercise 5A. Integration of exponential functions. If there's anything, just send them to me. Okay, so for this part of the chapter, you need to know that whenever you integrate sine and then some function of x, you would actually get cos fx divided by f prime x plus c. Okay, and then the other one is if you integrate cos fx, sorry, there should be a negative here. If you integrate cos fx, you would get sine fx over f prime x plus c. Okay, so if you think about it, since differentiation and integration are inverse functions of one another, so if you integrate cos fx, you would actually get negative sine fx times f prime x, right? Differentiating cos fx gives you negative f prime x sine fx. So if I were to differentiate negative cos fx, then I would get f prime x sine fx. If I were to differentiate negative cos fx divided by f prime x, then I would just get sine fx. So moving the d dx over so that I get like an inverse function. This is the inverse function of the derivative, which is sometimes written as the integral. So this guy gives you this guy with a c. Okay, so that's how you sort of derive it in the first place. Okay, anyway, the third thing that you have to know is, since we know that if you differentiate tangent, you will get secant squared. That means if you integrate secant squared, you would expect to get tangent. Okay, that's it. So that's the three things that you have to know. All right, let's do some examples. Yep. Let me show you some quick examples. Oh, there's a little caveat here, by the way. So the condition is that fx must be linear. Okay, highest power of x is 1. All right, first example. Let's say we integrate sine 1 minus 2x. Okay, don't forget your dx. Yeah. So what are you going to get? Well, you're going to get negative cos 1 minus 2x. And then what happens when you differentiate 1 minus 2x? You get negative 2. So you just put that at the bottom like so, and you're done. Okay? Another example. Let's say I integrate cos 3x plus 7 dx. Okay, what are we going to get? Well, we're going to get sine 3x plus 7, and then we differentiate 3x plus 7. That's going to give us 3. So I'm going to put 3 down here, and done. Okay, next one. What if we integrate sine 2x squared plus 1. So this one you cannot do using this method. Why? Because this is not linear. You can see the highest power of x is not 1, it's actually a 2. So you can't do it like this. Okay? In fact, this is not something that they would ask you. So if you ever get something like this in the exam, that means you probably messed up something early on in the question. Okay, one more example. Let's say we integrate secant squared 1 minus 7x dx. Okay, so we know if we integrate secant squared, you should get tangent. So you get tangent 1 minus 7x, and then divide by the derivative of 1 minus 7x, which is negative 7, and put a plus c. And done. There we go. Okay. Right. Now to show you something a bit trickier, let me just move this here a little. So what if they were to ask you to integrate sine squared x? So we know how to integrate sine x. We just get negative cos x. But if they ask you to integrate sine squared x, what do you do? So whenever they give you an integral, which is sine or cos, but the power is not 1, so it's greater than 1, you have to use the double angle formula to reduce the power to a 1 before you integrate. Okay, so what is a double angle formula associated with sine squared x? So if you think about it, there's a, or you can refer to the data booklet, whatever you choose. There's one equation that looks like cos 2x equals to 1 minus 2 sine squared x. Okay, you can see there's a sine squared x here, so let's try to make that the subject. That's going to give us 1 minus cos 2x over 2. Okay, so now we can express this as in terms of cos. Excellent. So now we can actually try to integrate this, because you can split this into 2 terms and then you integrate them separately. So the first term just gives you half x, and then the second term is going to give you sine 2x over 4, and then plus c. And there you go. That's how you integrate sine squared x. Okay? Let me show you another example. Let's say I want to integrate sine 4x. Oh no! What to do? Well, sine 4x is actually the same as sine squared x bracket squared, right? And we know what sine squared is using the double angle formula. It is 1 minus cos 2x over 2, and this whole thing squared. Okay, so let's expand this as you would normally with, a square. That's going to give you 1 minus 2 cos 2x plus cos squared 2x over 4 dx. There we go. And then we can take out the 1 over 4. And now you can integrate them separately. Well, for the first 2 terms you can. For the last term here, you can see that there's a square here. So you have to use the double angle formula again to get rid of the power before you can integrate. Alright, so let me try to do that over here. Suppose I replace my x here with 2x. What am I going to get? I'm going to get sine squared 2x equals to 1 minus cos 4x over 2. So you want to use this guy over here. Well, this one is actually cos. Sorry. I was using the wrong double angle formula. Oops, hang on. So what is a double angle formula involving cos squared x? Well, it's cos 2x equals to 2 cos squared x minus 1, right? So we're going to make cos squared x the subject, which is going to be cos 2x plus 1 divided by 2. And then we're going to replace the x with 2x so that it kind of fits what we have over here. So we're going to get cos 4x plus 1 over 2. There we go. So having done this, we can substitute that in here. And that's going to give us 1 minus 2 cos 2x plus cos 4x plus 1 over 2. And now everything has a power of 1, which means it is time for us to integrate each term separately. So integrating 1 is going to give us x. Integrating this guy here is going to give us sine 2x over 2. And then this guy here, imagine we take the half out before we integrate. And then we integrate cos 4x, which is going to give us sine 4x over 4. And then we integrate 1 over 2, which is going to give us 1 over 2x. And the whole thing is bracketed, and then plus c. So expanding this shenanigans, we get minus sine 2x plus 1 over 8 sine 4x plus 1 over 4x plus c. Hey, we done. So the trick here is to get rid of the power, right? All these powers by using the double angle formula. You either use this one or you use this one. And this is given in your data booklet. You don't have to memorize them. You just need to know how to do this. Okay? And then once you've done that, you expand everything and then you integrate each term separately using the basic rules over here. These rules. Okay? Now, I've only shown you how to integrate even powers of sine. What if you have an odd power of sine? What if it's sine cube x? Oh no, what should we do? Well, let me show you. Let me just move that down here. Let's say I want to integrate sine cube x dx. Okay, if you see an odd power, the first thing you want to do is you split it into one odd and one even. So in this case, you would have sine x and sine squared x. Remember, sine to the power of nx means the same thing as sine x and the whole thing to the power of n. Okay? So we can split this into these two terms here. So what's the point of us splitting it like this? Well, because the next step, we are going to have to use the basic identity, which is sine squared x plus cos squared x equals to 1. We're going to use this identity and we're going to substitute that into this sine squared x here. So we're going to get 1 minus cos squared x. And the reason we're doing that is so that we can get two separate terms that we can integrate on their own. So we're going to get sine x here, and I'm going to expand, and then sine x cos squared x dx. Okay? And then you have to use something called integration by substitution, which I just realized I haven't actually shown you how to do properly yet. Should I introduce that now? No, I don't think I should do that because I think it'll be a bit too much. So for now, we will come back to this later. To be continued. We will do this another class because I don't want to get you guys too confused with all these different techniques. We're just going to focus on the even powers of sine and cos for now. Okay? So just forget about this. We'll come back to this next class. Okay, so moving on. Let's do the examples for cos. Okay, so let me see if we can move it over here like this. Okay, let's say we want to integrate cos squared x dx. All right. So how do I integrate cos squared x? First, we have to use the double angle formula to get rid of the square. So which one do we want to use? We want to use this one right here. Okay, so we're going to get cos 2x plus 1 divided by 2 dx. And then you take the half out and then you integrate, which means you're going to get sine 2x over 2 plus 1 over 2x plus c. And done. There we go. Next up, what if we integrate cos 4x? So hopefully you're beginning to see the pattern here, because this guy is this guy and then squared dx, which is actually what we got earlier. That's cos 2x plus 1 over 2, and the whole thing is squared. Okay, and then you have to square it, so you're going to get 1 over 4, which I'll put out here, and then cos squared 2x plus 2 cos 2x plus 1 dx. And then this cos squared 2x, we can use what we got earlier over here. Gonna chuck that in here as well. And we're gonna get cos 4x plus 1 over 2. And then the usual thing, which I'll just write down. And then now you integrate each term separately. So the first one is going to give you, I'm going to take the half out first. Then that's going to give me sine 4x over 4 plus 1 over 2x. The next one is going to be sine 2x and then 1, well, it's just x. And then plus c. There we go. So expanding this, we get 1 over 8, 1 over 32, sine 4x, and then 8, 1 over 16x plus sine 2x plus x plus c. And done. Okay. Right, let me show you another example. What if they were to combine these with, let's say, something like that? So integrate sine squared 2x. Let's not do 2x. Let's do 7x plus 2 dx. Okay, what if it's something like this? Well, first let's write down our double angle formula. So we have cos 2x equals to 1 minus 2 sine squared x. Yes. And we're going to make sine squared x the subject. So sine squared x is equals to 1 minus cos 2x over 2. And then you can see here that because we have 7x plus 2 here, we want to replace this x with 7x plus 2. So we're going to write this as sine squared bracket 7x plus 2 equals to 1 minus cos 2 7x plus 2 over 2. So we essentially end up with cos 14x plus 4 over 2. Okay, so now that we've done that, we're going to chuck that in here. We're going to factorize out the half. So 1 minus cos 14x plus 4 dx. Okay. All right, so we're done. The next thing is we will integrate each term separately. So the first term is half x. The second term is going to be, what happens when you integrate cos? You get sine 14x plus 4, and then you differentiate whatever is inside the function, because you can see this is a linear function, so we can actually do that. We differentiate this, we get 14, so we should put 14 down here. And then times 2, because, you know, there's a half out there, plus c. So eventually we should end up with half x minus 1 over 28 sine 14x plus 4 plus c. There. There we go. Sorry, hang on. I need to send a quick message. One sec. Okay. Right. So, what if we have integrate cos 6x dx? Okay, if you have cos 6x dx, you have to do cos 4x. Sorry, you have to do cos cubed x squared, like this. And then you're gonna have to split this into cos x and then cos squared x. And then you're gonna have to split this into 1 minus sine squared x and then squared dx. And then this becomes cos x minus cos x sine squared x, and then the whole thing is squared. And then you have to expand it even further. And then you have to use integration by substitution, which is something that I haven't shown you how to do in detail yet. So we will continue this another time, to be continued. So for now, all you got to know is how to integrate sine squared, sine 4, cos squared, cos 4, and these 3 mini rules over here. Okay? That's it. So, even though we have finished the class very quickly, we still have quite a bit of time left, but I would like you to take the extra time to go through the questions, because it's very important that you work through the exercise, because the subsequent chapters are built on integration. Okay, so you need to have a very strong foundation, which is why I'm going very slow. Okay, so I would like you to do exercise 5B. I'm gonna try exercise 5B. And if you have anything at all that you're stuck on, just let me know, and I will work out the solution and send it back to you. Okay? Any question at all? Don't be afraid to ask anything, including any of the previous exercises if you are still working on that. So for now, just try 5B. Yep, just do 5B. And then next class, we are going to do integration by substitution. And then the following class, we're going to do integration by parts. So a lot of this, if you've done further math, you've actually done it before already. So this should be a cakewalk for you. Okay, anyway, we shall stop here for today. I'm going to send this to you guys so you could refer to this if you want to. I'm going to put it on the WhatsApp group. But yeah, please give this a go in the next hour or so and ask me anything you want to ask. Okay? All right. Bye-bye. I'll be here, so send me questions. See you guys.